think the stage is yours, Juha.
Excellent. Thank you, Peter. And hello, everyone. Good to be here. Good to have you all here. My name is Juha Korpala from Ellie Technologies. I have here with me Peter Bellas, and what we're going to be talking about today is creating a fully auditable business-driven data vault for a financial institution. That's the case we're going to be talking about. So what we have here is a two people from our respective companies now doing demos today for you. I am a Chief Product Officer for Ellie Technologies, doing the kind of business-focused part of this modeling exercise. And Peter, would you like to introduce yourself?
Yes, my name is Peter Bellis. I'm working since the year 2000 in the data warehousing business. I started with classical inman warehousing in the financial industry. I switched over to telecommunications, where we did more Kimball stuff, and back in 2012 I came across certain challenges that we needed to solve with the data vault modeling technique, and that's why I will in the second part present you how we created the data vault builder to solve this kind of issues, and especially as well addressing topics in the financial industry.
Exactly. So what we'll do here is that I'll start introducing the kind of business analysis side of things. I'll introduce you to Ellie. Few slides first, and then I'll do a demo where I create a kind of business-focused model of this our hypothetical financial institution. I'll show you a few things about that, how Ellie works to capture that business requirement of what the data is actually about, and then I will hand it over to Peter and Datavault Builder to utilize that model created in Ellie as kind of a blueprint for what happens next. And what happens there will be then building the actual data vault solution itself. So without further ado, let's keep moving. We'll start with an introduction to Ellie. And the key here is really the kind of second line of that topic. It's business-driven data design. Because what we want to do is understand what we are actually doing. We don't want to jump into creating kind of highly technical solutions for various data vault situations and so on immediately, before we understand really what we need to model. So Ellie is a tool to do this kind of design work in a collaborative and cooperative way, in a way that you can actually get understanding of what the topic is and involve your business stakeholders and so on. Utilize a tool that is very fast and easy, where you can create this view together before you start on more technical details. So Ellie is a completely cloud-based tool. You'll see soon how it works. Very collaborative, fast and easy way to get this thing done. In general terms, the way we work with Ellie is that you kind of create this two-layered, what we call a business-driven data architecture or business-driven data design process, where you identify what your data product, in this case with the data vault that we're going to be building, what does that actually need? What are the key things we have data about? And you can create conceptual models, you can create logical models, which are looking at that problem from the business angle. So if we consider different levels of data models, I'm not going to go into all sorts of methodological nuances here, but for us, how this works is that there's a business IT gap, really, which we aim to bridge with different sorts of data models. And on the left-hand side there, you see that the business glossary is an important part of this. So what do you mean by a customer or product or something like that? And when you have understanding of what these things actually mean, you can create a conceptual data model to explain the structure of what do you actually need to know, how are things related to each other in real life without looking at the systems where the data is stored yet. So we're creating a conceptual level model first of this subject area to understand what we actually need to build, and we will utilize that then in the kind of logical and physical steps where actually Datavault Builder steps in to do that in a proper way. So for us in Ellie, we take care of this early part of that, and actually, in fact, Ellie handles the business glossary, the conceptual data model, and logical data model as well. I'll just share a couple of words about that in a moment. Right now here in this particular case, Datavault Builder is able to catch from that conceptual data model point already. But for us, it's very important that we start from the left-hand side. We want to start with the basics. And the basic use case that we're looking at here is kind of designing these sorts of business-driven data platforms. This is a very common use case for Ellie altogether. There are a few others. I'm not going to go through those now, but I'll attach a couple of slides on the material regarding that, where the idea is here that when we start designing a data solution, a data platform, in this case now a data vault, we want to start with catching what the business is really about, and we start to design this higher level of structure, which we then push down to the technical tool, in this case Datavault Builder, which is then able to utilize that information to build something that is centered around the business objects. So you have your real business, you have your real description of what things are, and Datavault Builder is able to take that from Ellie and build something that is understandable for people. It is something that is easier to utilize, something that is kind of easier to serve to your data consumers, leading then towards, of course, more data needs and more data work and so on. This is a very common use case for Ellie, where it's kind of used as a requirements catch point, really, in this kind of a project. There's plenty of other slides as well. I mean, use cases as well, where we cover use cases like master data management projects, and there's data governance related initiatives. I'm not going to go into those right now. When we talk about these data platform types of projects, what happens with Datavault Builder looks like something like this. So first of all, when we are talking about Data Vault, the design should always start from the actual business entities, and this is really, really important. Dan Lindstedt has said that Data Vault is about the business, and it will always be about the business, and everyone is writing about the same things. If you look at Data Vault literature, it has to be about the business entities. So we're using Ellie to capture those. We understand the slice of reality that we want to include in our data vault. We create the conceptual data model. We create the glossary that explains to us what those things are, so that we have that shared understanding. And then we move to the data vault model being created in Datavault Builder, and there's an API-based integration here between Ellie and Datavault Builder. We're not going to go deeply into the technical details of that integration here today, but I will give you a brief example of what that approximately looks like. And this conceptual understanding of how world works is used then via these APIs in Datavault Builder. The important thing about this kind of data vault done right process is that this early part of the work is totally independent of technology. It doesn't really matter what are your source systems. You have SAP, you have whatever. It doesn't really matter, because you need to understand the business concepts first. And as you understand the business concepts, you are then able to utilize that conceptual understanding and glossary, the understanding of the terms, also in other kinds of use cases, which is why kind of the things that you do in Ellie are reusable, and you are probably going to be utilizing the exact same models, the exact same descriptions in many, many kinds of projects, not just Data Vault, not just in this finance institutions case, in account management or so on. It's something that is going to be useful for the entire organization. As a final slide before I actually jump into the demo itself, what is created kind of behind the scenes almost in Ellie is the glossary, which explains to us what things mean. So you have products, you need to figure out what is a product, how does that differ from a product category or product type or something like that. This metadata about these business things can also be added into Ellie. And in fact, there have been, for example, a previous webinar that we did with Peter, we were discussing about privacy. So you could add metadata into Ellie already to notify the users of that data, of those designs, those models, that, hey, this particular thing here, this entity or this attribute here, this is sensitive information that has to be handled separately somewhere. But all of this metadata is part of Ellie's glossary, and all of these items in the glossary are reusable across different models. And then you can see how these different data models that we create will start to link together, forming this kind of structure of the entire enterprise's information architecture. But today we're focusing on a single use case, a limited model, which I will create now just a second as I get the screen share right. So we will be now looking into creating a simple example model relating to banking. And what we'll be doing here is practically, just a second. We will practically open my personal Ellie account, which you can see here. As I mentioned, it's a SaaS tool, so this runs on my browser. There's no magic to it. It's available to anyone there. Very simple interface. We want to make this fast and easy. This is my personal account, so there's all sorts of stuff here. We don't need to worry about that. I'm just going to show you how to create a very simple model, which is supported by the glossary that we have that defines all these different terms. So we create the conceptual model. There are logical models as well, but I'm not going to go into that right now because we're jumping from the conceptual models to Datavault Builder in this particular case. But we start with a model, and this is now our banking example number 2. I think I used number 1 already, but as we see this empty canvas here now, the point is that we start to figure out, okay, what does actually exist in that slice of reality that our data is about. And at this time, we're interested in bank accounts and payment transactions. And we will be, Peter will show you later how we can handle the payment transaction data in a way that makes this whole thing completely auditable. But at these early stages where we are now with Ellie, we start with the very, very basic. So what do we actually have data about? So I have here a search or create field, and I can type here bank account, and it searches from the Ellie glossary for terms that match. So I'm going to use that bank account that I've created previously. Click and drag. This is all very simple. Click and drag user interface here. And we are interested, of course, in counterparties. So what sort of counterparties actually own those accounts? We can create relations saying that, all right, there is a one-to-many relationship between a counterparty and a bank account. And we can also define here that the nature of this relationship is such that the counterparty owns the account. This is now, of course, a simplification of a real bank, but we'll go with this. Then, of course, we're interested in payment transactions. So again, I'm picking entities from the glossary, which might have been created for some other models in some other case, and I could see how they are used there. But now this one is blue because we have entity types here which can be defined. So I've defined an entity type of transaction just so that the models are easier to understand. These are kind of master data type, and this is kind of a transaction data type. These are customizable. I'm just using this here to make it easier to read. So we're of course saying now that there are two relationships actually between a bank account and a transaction. We have obviously the account from which the payment is made and the account to which the payment is made. So we'll describe this here saying paid from, and we will say that this is the paid to relationship. And then obviously there is the counterparty who makes the transaction, which we can define here as such. So the counterparty makes a transaction, and there could be also a situation where a counterparty has canceled the transaction, but that might possibly be a different counterparty if they have access to the same transaction system. So we probably want to record both relationships here separately. So we write that, all right, it's possible that the counterparty makes a transaction and then someone cancels it as well. And one thing that we perhaps want to log as well is address of that counterparty. I will show you soon how this model could be further expanded, but this practically gives us the basic structure of the model that we're going to be utilizing in this particular example with Datavault Builder. So these are very simple things. It's a very simple model, but the idea is that this is something where we are figuring out what do we have data about without looking at the source systems. So we're figuring out this is how world works. This is what we want our data vault to contain. And if we wanted to expand on this model, obviously we could keep adding more details. So here you can see the basis structure is the same, but I have added all sorts of different detail here. There's different kinds of counterparties, organizations, persons, legal hierarchies, stakeholders, different kinds of bank accounts and branches and countries and so on and so forth, where with this kind of a larger expanded model, we could already start thinking about use cases like, for example, fraud detection or something do we have money going in or out from weird countries and so on and so forth. But for simplicity's sake, I'm not going to give this to Peter. We're going to stick with this one. One more thing I want to say about this before we start kind of moving forward with the data vault part is that all of this has the underlying glossary behind it. So I can double click on the payment transaction here, and I can see that there's metadata, and we could define what do we mean by a payment transaction. So we could write here that in our organization, a payment transaction is a single payment, you know, on a given date from a given account to another account, and so on. And so on and so forth. I'm not going to be typing all that down, but this is metadata about these entities themselves, which is kind of independent of the individual models. So the model now specifies that the payment transaction is paid to a bank account, but the payment transaction has its own metadata. And we can see here, we could add examples, synonyms, we could have custom information here, which could be used for integration purposes or something. We could add attributes. We could see how the model is being, how the entity is being used across all the different models we have in Ellie. So here we can see that in my particular example here, I'm using the payment transaction entity in 2 different models, which I've created recently, and I can see how it is linked to other entities. And I could, let's say, click on the bank account here and see that, okay, now there's actually 5 different models which are using this entity, and these are all the different links that bank accounts have with other data in the organization. So this is how you start to see that kind of wider picture. We have been creating individual models for individual use cases, but we're also starting to see how everything links together, and this is created automatically based on those models. Now, this is the example model we're going to be using, and what happens to that is that we practically just simply take that out of Ellie and give that model to Datavault Builder. For that purpose, we're going to be using Ellie's API. I'm not going to go into all those API calls or whatnot, but what I am going to do is just briefly show you how that works. There's the model ID that we have here. We're going to need that, so I copy that. And I'm going to do just a little thing here to show you how information is taken out of Ellie. So we have here a Postman application where I'm just simply sending a call to our API, and I of course have the wrong API token there, but let me just quickly fix this. But the idea is that these models can be utilized for all sorts of purposes, and even though the model that you created for a specific project, like here for our data vault, it might be something that describes a kind of much more widely applicable structure. So we want to be able to utilize these models for different kinds of tools, different kinds of use cases, different kinds of projects. So here we can see that my model 12016, which is the banking example number 2, contains all these kinds of information here. We have all the attributes, all the relationships, everything. And this is the thing that is going to be fed into Datavault Builder in a moment. But this could also be used for matching things up with your data catalog, or linking metadata to even your operational systems. How, you know, what information do we have about this particular thing that we're handling right now? So that is all something that we get via Ellie's APIs, as we are utilizing those to read the information out. And obviously we could also read information back in. So for example, if we had more metadata about payment transaction somewhere, we could just input that via those API endpoints into Ellie's glossary. But that's something to talk about later. I think now it's time for me to give this over to Peter. Go ahead.
Thank you a lot for all this introduction. And what I think is really important is that Ellie allows you to care about so many things about data, like adding the PII sensitivity, like adding the data owner, and all of this information is offered as well on the REST API. So you can interact with all of this and use this in the follow-up processes. So you could, like, as we did in another webinar, separate your PII data into specific satellites. You can read maybe data retention periods that you captured there and set up your automatic processes. And this makes it very, very flexible.
Indeed, indeed. And that's kind of the point here, that we're using Ellie to design things, and then that design is being utilized by Datavault Builder to do all kinds of things. Yeah.
Good. So what is the Datavault Builder about? And today's challenge is usually that companies don't need to find new data sources. They have a lot of data sources, but they don't bring it in good quality to the data consumers. So update it regularly, create history about it, consolidate it, don't create any data silos. And this is what the Datavault Builder is about. So if you look at it, what is the target? It's better data quality for analytical purposes, but sometimes as well for operational systems. So we sometimes act as data hub where several data sources are consolidated, maybe about product data, maybe about transactional data, and redelivered to other sources. It's about lowering cost and risk by using a lot of automation. And for us, very important, it's a faster time to insight. This means how long does it take if you have new requirements to like connect to a new data source? Maybe your company has bought a competitor, you need to integrate the data set. How long does it take from the requirement until you can deliver the data in production ready quality to your data consumers? So how does the Datavault Builder work? We start with a model. And if we work together with Ellie, a big part of this model is already created in Ellie. It can be that it will be maybe extended in the Datavault Builder for technical entities that don't have business meaning, but are important to be implemented because they create some kind of relations on the technical level. And we are translating this kind of business model in real time into working code. Working code means we're creating database tables, we're creating load statements, we're connecting to external data sources, loading them. And this is not the end of it. So the Datavault Builder covers all the processes around data integration and data warehousing. It starts by delivering this platform in an automated way that you can run it on premises, in the cloud. It really depends on what your requirements are. It includes REST APIs for regression testing. It includes modules for deploying your solutions from your development to your test and production machine. It includes logging. It includes operations by having a built-in scheduler, but having REST APIs to using external schedules. It really covers everything around it. So what I will show here in the live demonstration is really only a small part of what we are doing. If you want to see how we compare to other tools, you can download on our webpage the BARC study that will show you that we are top in the category of customer satisfaction, recommendation rate, and what I'm very proud of is the time to market category. So which kind of elements will we see now in the live demonstration? We have these blue boxes. These are the concepts corresponding to entities. We have relations between the concepts, and we have the small dots. The small dots contain the context about a concept. This means there will be attributes. It's like you can imagine if I would have a customer concept, there could be the name, first name, last name in a so-called small satellite tables. So if we translate it then at the physical level on the database, this will translate into a hub. The relation will translate into a link, and the small dots will translate into satellites. But as you are explained, if you're talking to your business, don't talk about too technical terms. Try to talk about business processes and let automation do the rest. So how does it look layer-like? So we have the core layer where we get the model from Ellie, and we generate at the physical layer. This means in your database, which can be one of the supported database platforms, which is Snowflake, Oracle, Synapse, SQL Server in all its variant, Exasol, Postgres, and now in being developed right now, the BigQuery version. We are translating this, creating the tables and everything. Then you can use the staging module. The staging module is connecting to different data sources, which are mainly JDBC sources, can be Excel file, Access databases. Through gRPC, we can connect to Python scripts. Through the Trino connector, we can connect to Kafka, Parquet files, or Iceberg files. And then by defining the business key, we can connect directly the staging layer to the target. And you have two options. You can do this process in the Datavault Builder in a data-driven perspective. You could already collect this information in Ellie and collect column level information in there and transform that. It's really up to you, because the integration between the two tools is based on open APIs, on documented APIs, and the mapping. What Ellie entity means in Datavault Builder is up to you to be defined, as example, in a Python script, and you can map it as you need it. So the next step is when we have loaded all the data and we're creating automatically history. This is an important part as well in the finance industry. Then you can decide what the output shall be. And we have again and again requests, but could this be third normal form? And we say no, third normal form is possible if you want it, but then it's an output interface. Most clients but ask for dimensional output. That's possible as well. We have some data scientists that want to have flat tables. We can generate that. Or if you are more in a data mesh environment, how to create data products. On top of that, you can create virtual rules. If you're coming more from an Inman design, then you would ask, why are we not doing the business rules in here, but at the end? And the reason is, like this, we can materialize the data as it is. We create a unique source of facts, and we can modify the rules in a very, very quick, in a very, very agile way. And the Datavault Builder is covering all of this process until your data gets from the source delivered to your reporting tool. And the interface will be at the database level, a view that you can connect with Power BI, Qlik, Tableau, Cognos, sub-business objects, or operational application. So that you just see for a short second the full overview. It starts with infrastructure, goes through modeling, data profiling, code generation, testing, deployment, automating of deployment, operation, high availability. But we will cover here only the first bit in the live demonstration. If you're interested in all the other things, then you're happy to join one of our standard webinars where we go more into details of all the different steps. So we will be replacing now many different tools than we used in the past with one single tool. And now let's go and jump into the use case. So what are main drivers if you're talking to insurances, if you're talking to banks, if you're talking to other companies in this business? It is often about auditability. It's about documentation, data lineage, data ownership. And here we have a little bit of shared responsibility, because in Ellie you can collect some of the manual metadata that you want to do, but we are taking all of this information, and from the model that we have in real time, we're converting it into a technical implementation. And we are doing this in a very standardized way. This means we can show you exactly for which entity that we were sent, which table exists in the database. And this process is two-way. So if somebody would change the implementation, we would update as well the model, so you know exactly that your model matches the implementation. So if you had it in any situation in the past that you had the audit and you were not sure if your documentation matches your implementation, you will never have that again with the Datavault Builder, because that's a two-way thing and it's in place. At the same time, while generating the objects, we're generating documentation and data lineage. And now you could go to Freight and say, okay, if this is real time, what happens if you change something by accident? You're not doing this kind of process on your production system. You're doing this in your development environment. Maybe if you're even a bigger team, as usual in banks, then you would have maybe distributed development. Every developer gets his own sandbox, and we have then a Git flow-based process which transports this kind of changes between environments. But again, as soon as it was transported through the Git flow-based process to the next environment, the implementation and the documentation will always match, because these two things at a certain environment are always in sync. So what is a second challenge? And that's a little bit what I want to address here, because this is one of the more difficult topics, in my opinion, is temporality if you have different timelines. And here I will simplify it. I know that if you're in the insurance business, you might have 5 to 6 important timelines to you, but I'm reducing it here a little bit to the general case, that for something that we see again and again in many different companies. So one dimension of your timelines is business validity. So if you have a contract, You maybe have a different version of the contract for 2022 and a new version of 2023. Just because you have a new version of the contract this year doesn't mean that the other is invalid. It's just not anymore current. So both of them are valid. We have different instances of this, and this is something that we can model in the Datavault Builder by creating, besides the contract element, as well a contract instant element that representing the different versions of the contract that were valid at any point in time. I will not focus on that. If you're interested in that, there's a whole blog series of about 4 articles on our webpage explaining exactly the different steps, how you can simplify it, how you can model it. The second thing is the posting date. And this is something that we see very often. Many banks do post their data at the end of the day to the analytical systems. This means all the transactions that happened on that day, all the master data as they were as of this day are being posted. And this is like the version end of the day, what was valid. And the third dimension that we have is when we got knowledge about this different data in the data warehouse. So here, usually we have the concept called load time. We are differentiating that from validity, as it was maybe used in the past, from valid to, because this confuses people between business validity and this load time axis. And this third time axis is very, very simple in the data vault modeling, because by design, all the data that is loaded into the satellites is stamped automatically with the load time. So we know when the data was arrived there, if we need to be able to reproduce a report as of knowledge of at a certain period in time, that's perfectly fine. That's very simple. So if we look at this problem, so this is by design, this is something that you can solve through the proper modeling. So let's have a look at this posting date issue, because usually if you would address this manually, you would need to create your own ETL flows or SQL logic to process this kind of data. So what is the example that we will look at? So we have a transaction. By chance, it's transaction 001 that has a business validity of the 29th February 2023, which for sure didn't exist if I look at it. But it was posted as well on the same day with an amount of 101 euros. And this was posted end of the day, and this was the reality. Until next day, somebody figured out the export was wrong. The transaction, in effect, was about 100.50 euros, and it was rounded in the export. So this is a correction. So the business validity is still the same because nothing changed on the business itself, but the posting date when we got this data exported from our banking source system was the 1st of March. And now we need to be able somehow to cope with that. So what do we need to do? And here, this is the data as we received it, and you see it here. It's already corrected because the 29th of February doesn't exist. 28th of February, we received this data, and for transaction 001, we had 101 euros. And the next day, with a posting date of the 1st of March, we received now this correction. So for the same business key, for the same transaction, we now get 2 different information. And yes, you could then maybe receive in different loads. That would make the thing simpler. But if you're using something like a data lake in between where you store all the files, it could be that even you need to at some point process both of the information at the same time. So you need to take into consideration the posting date. So how do we do that? In the Data Vault Builder, it's very simple. We tell the Data Vault Builder that one of our source columns, in that case, the posting date, is in fact our inscription timelines. This is the external timeline that the Data Vault Builder should use, at which it was either written or exported. And this should be our leading timeline when we will later on evaluate the contents of this data. Next step is we create, as usually, a core business concept and context for it. So it's a hub with a satellite. We don't need to specify anymore because we told already the Datavault Builder that we have one column with external timeline. So what it will do is it will take this timeline, store the posting date as the relevant timeline. But if we receive for the same posting date, like here, this is our case where we get a correction, two information at different point in times, it will still manage the load time separately from the posting date. And in fact, what we're doing here is we're creating a so-called bi-temporal satellite. So we get information from the source at different point in times. We're storing what we received, plus we store the moment when we got knowledge about it. And this creates, in fact, a terrible mess because now we have so much information that nearly nobody interested in. So what is the proper way to use this kind of in reporting? It depends. If you do fraud detection, it could be that you really go to the bi-temporal information and you extract exactly what changed over time, if there were any backwards corrections. But in many cases, you want to have a so-called either STD type 2 view, which gives you the full history on the posting date line, or you want to have a STD type 1 history on the latest information as of posting date and as of load time. Is just the latest information, like maybe what is the customer's name. If you want to write him a letter, you don't care about the history, you need his current name. And this would be the STD type 1 name. Now in Datavault Builder implementation, there are different objects that need to be created, like PIT tables, like different indexes. And all of this is very troublesome if you need to create it manually. But the cool thing is that it can be derived from this model definition and the definition, which is your external timeline. We can do all of this in the background. So you will see if we will really do this in the tool, that we don't need to know anything about it except of understanding that it is happening in the background. And what the output then will look like is it will write automatically history that from the 28th until the 1st of March, the 101 euros was the information that we knew about it. And from the 1st of March to the next change, the new value was valid. So let's have a look at how this looks in the tool. So we received now the model, and I'm not going into detail how we loaded it here. If you want to know more about it, on YouTube, you will find a video explaining how the APIs are used. In fact, the recommended way today is usually using some kind of Python scripts that read the metadata, map it to the data types in Datavault Builder and load them in here. But as mentioned, you can find that on YouTube as well. Here, let's assume we have taken over the model that we have loaded here. You will recognize that you see the same elements here, the relations created link tables, but we haven't connected it yet to data. And this is the part that we now do in Datavault Builder. So I go to the staging area, and here I could connect to many different source systems. We have already the built-in connectors, but if the data is already staged in your database, that would be fine as well. Or if you use some kind of data lake technology to store it in Parquet or Iceberg files, whatever, that would be fine as well. You could have an input system that gives you a stream, maybe a Kafka stream where you connect a topic and convert it here into mini batches. And then you can select here directly from the source system the different tables that are present there. So now instead of doing something hypothetically, creating columns here, we go really in a data-driven perspective. So this is really after we finish the business-driven part, we go now and we look what is there in the source systems, and then we can connect these two perspectives together. And it's reading as well already the data types. There are different ways to do delta loading, to do connect to CDC streams. I skip all of that because what I'm interested in is this one example about the payment transaction where we got a change. And if I look here in my very simplified sample data set, and we can filter here for the transaction that I mentioned, is we see here that we have the transaction with 101 euros and the corrected ones. And by the way, what we see is that the same counterparty exists in two different branches. So that's something that maybe we need to take care of when we load the data vault. So the next step is that we would go is that we can now have a look at our data. So we could maybe like filter here how the value distribution is between different values. And we see we have a branch 100 and 200, whereof the branch 100 has more transactions than 200. So we can go already in the data trying to understand is what the data is about. And in the next step now, we will map the data-driven perspective to the model-driven perspective. And here we need to define the business key. So we select the table that we have seen before. And we can now take here already the transaction ID. And now I will ask the Datavault Builder, is the transaction ID unique in this source system? And if we go back here, let's do the transaction ID here. Filter for. It looks like it is not. For the same transaction ID, we get two kind of informations. But because we defined that the posting date is our external timeline, and these two information are not valid for the same point in time, the Datavault Builder knows that this is fine, that we can load that. We know how to handle that because we will load anyway a BI-TEMPORAL satellite. So we can now go here to transaction, select now the transaction ID and check for uniqueness. And it tells us if we take the timeline into account for any point in time, there's only one version of this information available. So that's fine. I can load that. And if you know the Datavault Builder a little bit, the process doesn't look different than from creating a normal satellite. It's just by defining that we have external timeline, it knows now that this here will become a BI-TEMPORAL satellite. It creates the target table. It creates the right indexes for SCD type 2 and 1 queries. It loads the data. And like before, just in a few seconds, the data is loaded and we can have a look how it looks like right now. So we can now look for the transaction ID 001. And we see now that both versions were loaded, which is perfectly fine. They are linking to the same hub key. Everything is done and production ready. This means that in the background, data lineage was updated. It means that operations job was updated. So if we have a look on this job, then we can directly start here loading the job and it will be just fine. We can jump in there back later. But the last thing that we need to do is to query the data, create all the pit tables. And if you would need to do this manually, it would be a pain. But here, again, we look more at the business perspective. So we say that we want to export this kind of data, that we want to have it as of now. So I select here SCD type 1. It will just select the latest information automatically on the timeline of the inscription time or posting date and on the timeline of the load timeline. So if you look into the amount, and let's take here as well the transaction ID into it, we will see that here now for transaction 001, we have only one record because this is the latest information we received from the source system. Now, let's say somebody is interested in the history of how changes happened over time. So let's create the same thing, but now with a different time perspective. We select SCD type 2. Now it's creating the pit tables. That's why I will need to reload this kind of information. Let's do the same here. Let's take in the transaction ID and the amount. Let's store that. Now we can trigger here this kind of a job. And if we go back here, we see now exactly these changes, and it calculated automatically that it was valid from this posting date until the next one. And this one is valid until infinity. And I didn't need it to define anything. Everything is based on standards. So it's very, very simple to solve this kind of standard problems that many people have if they have BI-TEMPORAL data or if they have CDC streams as source. And if we jump back into the presentation, what you haven't seen is that we solved already many more problems than I could show in a short time. So if data is redelivered with different posting dates, even nothing changed, like there are banks that are exporting all their master data every day with a new posting date, even nothing changed. We are already compressing the data. We are not storing always, again, the same data, but we're reducing it to store a minimal amount of data about this. If data arrives out of business validity, because somebody did a change backwards, that's fine. If data arrives out of order based on the posting date, that's fine as well. Even if we compress data, we remember which data we compressed. So if there is a backwards change on the posting date timeline, we will reinstate values that are necessary to create a proper timeline. If you don't have the problems, that's nice for you. If you have them, you probably know what I'm talking about and which kind of complexity is in there. So in fact, this is the technical solution in the background, but we're not showing you that. You just do, based on definitions, what you want to achieve, which kind of information you want, and in the background, the Datavault Builder is doing all the technical magic for you. So let's bring Juha back on, and let's see if you have any questions. There is a question and answer button at the bottom. If you have any questions, just click it there and you can type in your questions. Okay, so what is happening with the data? Because you have mentioned that it's a cloud-based solution. That's true for modeling. I think you can comment on that. I can then comment on the data part.
Sure. So indeed, Ellie is cloud-based solution, but as I mentioned, we are not kind of thinking even about the source systems at that stage of design. So the work that you do in Ellie is actually not connected to your actual source systems. So you don't need to worry about your data being exposed to anything. You are simply doing design, which is just metadata in the end, which is then being passed to Datavault Builder before any actual data is being touched. So from that point of view, it's very, very straightforward with Ellie.
And on the Datavault Builder side, you decide on. We have clients running the Docker containers on premises. We have clients running them in their Azure or AWS tenant. And we have as well a managed solution, but the managed solution again is that one partner of us is delivering you a managed service into a specific resource group in your Azure account. So again, it's completely isolated within your control. The software has no calling home functionality, so we are not sending any information out. And if you want to then connect like Ellie with Datavault Builder, you need a PC that is able to download the model from Ellie and push it on the Datavault Builder. It doesn't even need to be the same machine somehow, but you need to somehow be able to transport the meta information. That's the only thing. Good. One question is this only applicable to the finance industries? No, we have as well, but it's very less common that we have BI-TEMPORAL data. That's why we call this webinar like this. But as you already showed, you can use this for any kind of processing. We have classical sales cases. We have medical companies using this kind of information. I think it's always as soon as you have more than one data source that you need to integrate, then it becomes interesting from the Datavault Builder part. And I would say can you comment? I think that's very similar for you.
Yeah, indeed. So we have Ellie users from all kinds of industries, technology, manufacturing, you name it. I think, as you mentioned, the key thing is that if you're integrating data from multiple places, you kind of have to be able to model it in a single kind of coherent whole. And that is something that you need to deal with no matter the industry. Of course, financial industry tends to have its own little issues, like the BI-TEMPORAL, the thing that Peter showed you there, and of course highly kind of sensitive nature of the data there, but the basic workflow, the basic design principles remain the same.
So let's do a very short questionnaire. I would ask that I know a little bit of if you're actually having in your own company or with your clients this kind of challenge, that we get a little bit impression if if we at least got the right topic.
I mean, I've faced this personally in multiple industries that have nothing to do with finance. So I would suppose I will actually also answer yes then. Oh, I can't vote. Oh no, I'm a host. I can't vote. That's too bad. Yeah,
no, that's an interesting thing, that we had it even with industrial companies that like doing manufacturing and selling stuff, and they told us, no, we have no bi-temporal data. But when you look then at how processes are running, and that they need to capture exactly the steps when they happen, and they have at the machines the snapshots when things happen, then they have their external timeline, and then they get knowledge about it later because they have like log collectors running only weekly and stuff like that. So yes, it happens more often than we think.
absolutely so.
So yes, we have 15 yes and 4 no. So at least some of you understand which kind of topics we described. For all the others, I hope you profited as well a little bit about this, separating the business modeling from the real implementation, which I really support strongly. I believe this is the right approach to go, because it raises the awareness, the understanding of what you're doing, and it's much more stable than technical implementations. So it's very cool, because usually your technical implementation may change over time. Your business model usually stays stable. And if the business model doesn't stay stable, then your technical implementation changes anyway. So it is the better way to invest in your proper business model.
Yeah, indeed.
Maybe just one last tip from my side. Don't try, because people, when I started, try to do it like the enterprise data model for like 7, 8, 9 months of modeling, and then started implementing. Don't try that. And I think this is not what Ellie is built for.
Yeah, I mean, absolutely. I mean, sure, you could do it with Ellie, but
Yeah.
that's actually what we also keep telling our new customers, new users, that, hey, don't try to eat the whole elephant and in one go. But because, you know, as you saw in Ellie, the models are all interconnected. They're all built around the glossary. So you can just simply model little pieces here and there, and they will all interlinked. And that's how you eat the elephant, bite at a time. So certainly so.
So you really eat elephants?
I don't know. Is that actually is that something that you can say in English? It's saying in Finnish.
No, no, no. Okay.
Okay. Well, then my metaphor might have been a little bit odd, but yeah.
No.
You eat an elephant one bite at a time.
That's fine. So if there are no more questions for the moment, I would happily invite you to join one of our webinars to get more information about details. Juha, you can offer, I think, a free online.
Yes. So what we have to offer is a 30-day free trial. Ellie.ai, as you see in the logo, there is the website. You can get the 30-day free trial. There's also all sorts of material on the website about our use cases and partners and customers and so on, and all the different things you can do with Ellie. So check out Ellie.ai and get yourself a free trial.
Okay. So Juha, I thank you very much. I thank all the people that attended for your interest. It was a pleasure, Juha, and
Likewise.
I hope to see everybody soon as on another occasion. Thank you a lot.
Thank you all.
Bye.
Bye-bye.